Welcome to Ask and Learn.
For this problem, since we have factorials, we should be thinking about the ratio test. Typically, factorials are kind of hard to deal with. In the ratio test, they're not so hard to deal with. So these guys here, these are the AN terms. For the ratio test, we want to see if this is less than 1, strictly less than 1. If it's equal to 1, then the test is not conclusive. Okay, so like we said, these guys are our ANs. So if we're looking at AN plus 1, replace the n in this equation with n plus 1. And then dividing by AN is the same thing as multiplying by the reciprocal. So we would have n factorial here, 3n here, and then n squared here. Whoops, and it's a fraction. Okay, so then in order to look to see what cancels out, we want to look at, this 3, this 3. So here we have 3 to the n plus 1. Here we have 3 to the n. So you want to be comparing those guys, see what cancels out. So all of the copies of 3 are going to cancel out except for one copy of 3, which will be left over from up here. So we get one copy of 3 remaining up top. N factorial divided by n plus 1 factorial. We're going to get a lot of things to cancel out except for n plus 1 down here. So remember, n factorial is just 1 times 2 times 3 times 4, dot, 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 all the way up to times n. So if you just write out the definition of what the factorial function is, then you'll see that there's going to be lots and lots of cancellations. Everything will cancel except for n plus 1 down here. So then what we're left with is n plus 1 squared divided by n squared. So we can write that as n plus 1 over n squared. Okay, and then if you want, you can, if this isn't clear what this limit is, you can split it up like this. Okay, so this is something that we're allowed to do as long as we don't split it up into something that puts us in indeterminate form. Like, if this limit was infinite and this limit was 0, then we wouldn't be allowed to do this type of thing. But in this case, this limit is going to be 0, and this limit is going to be something finite. So 0 times finite is not indeterminate form. So we're definitely allowed to split up the limit in this way. And this limit, if you just pull this limit inside of the parentheses, you'll see that this is just going to be 1. So then we'd have 1 squared, which is 1. So we get like 0 times 1, which is 0. And again, the important part there is that it's something that's less than 1. So we do get convergence. Okay, and if this is obvious enough that this limit is 0, you don't have to split it up into these two limits like this, but it's a nice intermediate step if you're unclear about this. Another approach you could do is you could write that, this copy of n plus 1 gets canceled out with one of the copies of n plus 1 over here. Right, so you end up with something like that, and then you could use L'Hopital's rule or something to figure out that this goes to 0. Or you could do the trick, once you ended up here, you could use the trick where you divide both the top and the bottom by n squared, and then take limit on top over limit on bottom. So there's a few different approaches that you can use here, but you should end up with this thing approaching 0. And again, it doesn't need to go to 0. We just need for it to be less than 1. So if it's 0, then we certainly accomplish that and we get convergence.